So hi everybody. In our previous lectures, we discussed about what is distance, what is displacement, and what is speed, what is velocity, average speed, instantaneous speed, average velocity, instantaneous velocity, what is acceleration. So all these things we discussed earlier in our previous lectures. So today I will be discussing more over it and. So suppose this is our initial point. This is our final destination or final point. This is the distance traveled. So suppose this one is, you can say, uh, S1 distance. This one is S1 distance. This 2 is S2 distance. This 3 is S3 distance. This one is S4 distance. This one is S5 distance, and so on to the last. This one is Sn distance. Now the speed while traveling this distance S1, the speed suppose is V1. While traveling this distance S2, speed is suppose V2. While traveling this distance S3, the speed is V3. While traveling this distance S4, speed is V4. While traveling this distance S5, speed is V5. And while traveling this distance Sn, the speed is Vn. So while moving from point A to point B, or you can say while moving from initial position to final position, uh, there was in change in velocity. Like for S1 it traveled with the velocity v1, for S2 it traveled with velocity v2, for S3 it traveled with velocity v3, for S4 it traveled with velocity v4, for S5 it traveled with velocity v5, and for Sn we traveled with velocity vn. So how to find out uh, the so we are going to find out the average speed. So how we are going to calculate it? It will be, you can say, total distance over total time. So like uh, for S1 distance, what would be the time taken? That we already discussed. S1 is equal to uh, like we discussed, speed is equal to distance over time, that we know. So what would be time? Time will be equal to distance over speed. So it will be like the time t1 will be, that is distance s1 over v1. Similar is the case for s2. The time taken will be T2 is equal to, how much it will be? S2 over V2. For third one, the time taken T3 is equal to how much? S3 over V3. The time taken for this one, T4 is equal to S4 over V4. And what about this last one? The time taken Tn is equal to how much? Sn over Vn. So you can say this is the time taken, like this is suppose this point is A1, this point is A2, this point is A3, this point is A4. So this is the T1 is the time from A to A1. T1 is the time from A to A1. T2 is the time from A1 to A2. T3 is the time from A2 to A3. So what would be the total distance? Total distance will be S1 plus S2 and S3 and so on to Sn. And what will be the time? Total time, that will be T1 plus T2 and so on to plus T3 and so on to Tn. So this will be S1 plus S2 plus S3 and so on to Sn over, what will be T1? S1 over V1, S1 over V1 plus S2 over V2 plus S3 over V3 and so on to Sn over Vn. Now suppose if if we consider a case like, let us suppose S is equal to S1 is equal to S2 is equal to S3 is equal to S4 and so on to is equal to Sn. So means what I am saying, that all these S1, S2, S3, S4 is equal to S. They are equal and that is equal to S. Then what will be our average speed? So in that case average speed will be, what it will be? S plus S and so on to S. How many these S are? Ns. Okay, and this will be S over V1 plus S over V2 and so on to S over Vn. So this will be Ns over S over V1 plus S over V2 and so on to Vs over Vn. This will come out like this: N over 1 over V1 plus 1 over V2 and so on to 1 over Vn. Okay, so this type of situation, if it comes in, means if you face this type of situation, so this is how we are going to tackle it. Okay. Suppose this is our initial point, this is our final point or final destination, you can say. This is the distance traveled. So suppose like from here to here the speed was v1 and the time taken is t1. From here to here the speed is v2 and the time taken is t2. From here to here the speed is v3 and the time taken is t3. From here to here the speed is v4 and the time taken is t4, and so on. From here like speed is vn and the time taken to complete this part is tn. So what would be the average speed? Like in this scenario, what would be the distance? As we discussed earlier, speed is equal to distance over time. So what would be the distance? That is equal to speed into time. So here distance will be equal to, you can say S1 distance is equal to V1 T1. Here the distance will be equal to V2 T2. Here the distance will be equal to V3 T3. Here the distance will be equal to V4 T4. Here the distance will be equal to Vn Tn. So what would be the average speed? That is equal to total distance over total time. That will be, you can say distance will be v1 t1 plus v2 t2 and so on to vn tn over total time, that will be t1 plus t2 and so on to tn. So this is how, and this is how we are going to calculate the average speed in this scenario. Okay, so let us suppose a case in which this t1 is equal to, like t1 is equal to t2 is equal to, and t3 is equal to t4 and so on to is equal to tn. So means all these times are equal to t. So what would be the average speed in that case? Average speed will be, that will be equal to, like here it will be v1 plus v1t plus v2t and so on to vnt, and what would be this one, t plus t and so on to t. So this is how much, n times. So it will come out like v1 plus v2 and so on to vn. T will be common and upon n t. This t gets cancelled. So it will come out v1 v2 and so on to vn over n. Okay, so in such type of scenarios you can say this is how we are going to tackle the situation. So like I told you, what acceleration means, like suppose like this is your initial point, this is your final point. Like here velocity is you can say initial velocity is 0, and suppose at this point it reaches here, means its velocity is uh, 0 plus 2, you can say meter per second, you can say it's 2 meter per second increased here. Here again 0 plus 2 plus 2 meter per second means it becomes 4. Here it's 2 velocity. What is this velocity? What is this velocity? So you can see here that the velocity is increasing. It's not constant. Means here it means it keeps on increasing from here to here. So means it is accelerating. You can say it is accelerating. Suppose I keep on measuring it, like here suppose it reaches, it becomes 2, 0 plus 2 plus 2 plus 2 means all these distances suppose are equal, so it keeps on increasing. Here it becomes 6 meter per second, so it's constantly increasing. Means you can say velocity is increasing means it's accelerating, you can say it's accelerating, because here the velocity is increasing. Okay, so this is what is called, but the thing you can see here, like suppose these all intervals are equal. Suppose if these all intervals are equal, so you can see here that it's increasing in a proper way. Means so like we can say here, like here it's increased, here 2, here it's again it's 2 increment, you can see here it becomes 4, again it's a 2 increment, it becomes 6 and so on. So it's a constant increase, so means acceleration is constant. So how we are going to calculate the acceleration? So like I discussed, like there is one average acceleration and there is one instantaneous acceleration. So what is average acceleration? That is change in velocity over time, distance, speed, sorry, velocity and speed. So that was limit delta t tending to 0, delta v over delta t, or we are going to do it differential. I told you it's v, dv over dt. That is you can say a differential part, a very small part. Means here what delta t is, delta t tending to 0, in this way we are going to denote this instantaneous, and actually it's a part of calculus, so that you will come across, but for the time being remember this thing, because we will be using it. We will see how to implement this thing in future, so future classes. So actually the thing is that there are three equations of motion. You can say that v is equal to u plus at, s is equal to ut plus half at square, and v square is equal to u square plus 2a s, where this v is the final velocity, u is the initial velocity, a is acceleration. So if it's acceleration, then this one will be positive. If it's deceleration, then this one will be negative. This is the time taken. This is the second equation. This is the distance traveled. This is initial velocity. This is final. This is time, and this is acceleration. This is time. This is final velocity. This is initial velocity. This is acceleration. This is distance traveled. Like this one is final velocity. This is initial velocity. It's acceleration. This is time. So like I told you that acceleration is equal to dv over dt. Just now I told you, I think a few minutes back only, in instantaneous acceleration I told you this thing. A is equal to dv over dt. What is this dv? That's a differential velocity, and this is differential time. We can write it this like this, like this is a dt. We can write it like this. Now, there is one thing that is integral calculus. There is one thing that is actually, for the timing it's a rough portion. Okay, so like there is one thing that is integral calculus. So integration is denoted by this sign. Like here what I told you, these are differential elements. These are differential elements. So when we are like when we are going to integrate all these, integrate means, you can say in simpler word, it's a joining of those differential elements. So when we are going, we means how to join it, that's a part of calculus, you can say. But the thing is that this type of sign is used for integration. We used to put range here, from here to here we used to put the range. So like here what's happening, like suppose consider situation, this is our initial point, and this is our final point. Here the velocity at initial velocity was u, okay, and here the final velocity is v. Here the final velocity is v, and the acceleration is a. Acceleration is a. So means, like for this what we have instantaneous. This is what is instantaneous acceleration that I discussed earlier in few minutes back only in our this class only. Let's say instantaneous acceleration means acceleration at any particular instant. Suppose at this instant the acceleration is, actually acceleration is constant, it's not variable. Acceleration in this journey from initial to final point is constant. So like suppose at this particular, you can say instant, at this particular instant you can say there is a difference in velocity, very difference, small difference, that is dv. Means what dv means? This is the differential increase in velocity or decrease in velocity. It depends whether the body is accelerating or deaccelerating. Means for this particular differential element, the change in velocity is dv, you can say, and the time, that is dt. Means for this differential element, for this small element, means for any particular instant, for any particular instant, the change in velocity is dv, and the time taken to change in this velocity, means the differential time is dt. So this is what these things are here. So like we wrote it here, dv is equal to a dt. So like for a particular instant it's like this, I calculated like this. Means I have acceleration a is equal to dv over dt. So how, when we are going to integrate, like here also there is some differential element, here also there is a differential element, here also there is some differential, means this dv over dt some might be here, here also it's here, here also it's here, here also it's here, here also it's here, and every point in this line there is, you can say, differential element is there. So that's integration, means we are going to integrate all these differential elements. We are going to integrate all these differential elements. So means we have to integrate it from this initial point to this final point. So what is initial velocity here? This is dv. So like here we are going to write initial, and what is the final velocity here? That is v. So we wrote it dv here. As a is constant, there is no need to write anything. Time taken, like t is equal to 0 here and t is equal to t here. Like t is equal to 0 because it's t initial, that is initial. Like here we used to write the initial value. Here we used to write the final value. Final value or range. So it's 0 t dt. So how we are going to like differentiation, how it is done? So like if it's like integral sign is here, I wrote it dx, so it will become what does it mean, like integration of x raised to the power 0, because it's x written over here, x raised to the power 0 means, because anything raised to the power 0 is equal to 1. Anything raised to the power, like we know, anything raised to the power 0 is equal to 1, that we are already familiar with this thing. So means I wrote it here because I want to tell you how the integration is done. So means like it will become like this: 0 plus 1 0 plus 1 over 1. So it will become x over 1. Suppose if it's like this, integration of x dx, so how this will be done? So like this will become integration of this power is 1. So 1 plus 1 over 1 plus 1, that will be equal to x square over 2. Suppose the integral of x cube is there, x cube dx is written. So how it will be done? 3 power is there. So x 3 plus 1 over 3 plus 1. So for the time being, this is how you should remember, this is how the integration is done. Okay, so what it will come out here, like here it will be, this is how we are going to denote it, like this will come out v, and the range we are going to write it like this is initial, this is final. So we are going to write it here also. When integration is done, so it will become t 0 to t. Next, what would be the step here? Like here the way of writing it like this: we have to put this v here, substitute this v here, and minus this v here, means v uh, like suppose I wrote it v1 here, it means its initial velocity is u and final velocity is v1, because it looks confusing here, so I wrote it v1 here. Okay, so this will become v1 minus u. Here what it will become? A, I am writing it t1 here. Okay, this is the time t1 it took from here to here. Okay, so this will become t1 minus, means this one minus this one 0. So what it will come? v1 is equal to v1 minus u is equal to a t1. Yeah, v1 is equal to u plus a t1. You can see that this equation we derived it, like this equation we derived it, this is the equation we derived it, this is this equation that we have here, like this one we derived it in this way. Okay, so this is how you can see how we did it. Now let's see how the second equation will be done, how the second equation will be derived. Like I told you, what is instantaneous speed, like this is our initial point, this is our final point, this is initial point, this is final point. So I told you one thing that is called the instantaneous velocity, like at any particular instant, suppose the distance traveled is ds, distance traveled is ds, and the time taken is dt. So what would be the instantaneous? That is v is equal to ds over dt. So again we are doing something like this. ds is equal to v dt. We are going to integrate it, because suppose this is the distance is s. So when we are going to integrate it like ds v dt, so like here the distance is 0 and here it keeps on increasing, it become s. So we are, you can see here we are integrating all these differential elements. We are integrating, we are joining all these differential elements. So like here its initial, you can, so it will become like this s. Okay, and the time taken, because here the distance is 0 and here it keeps on increasing, here it will be something, here distance will be something, we are going to integrate all these things. So here time is t. So our equation will look like integration 0 to s ds is equal to what v, like we will be substituting this part here, u plus a t and dt. It will become like 0 to t dt. What it will look like? 0 to t u dt plus integration 0 to t a t dt. I told you how the integration is done. So for this one it will become s ranging from 0 to s. For this one ut 0 to t plus here as a is constant, so it will become t square. This t is integrated, so d square over 2 0 to t. So like here it will become s minus 0 ut minus 0 plus a t square by 2 minus 0. So what this equation will become? This will become s is equal to ut plus half at square. Okay, so you can see this is how this equation comes out, like this one. So this is how this equation comes out. Okay, now there is a third equation also. Now we'll see how to derive this third equation. B square is equal to u square plus 2s. Like I told you, a is equal to dv over dt. We are going to do it like this, dv over ds. Like suppose dv over dt is here, I am putting ds like this, so both gets cancelled, so that's why I put it here. So it will become like dv over ds and ds over dt. Like these ds can be cancelled, so I did it like this. So like what ds over dt is, like here we saw earlier, so we can write it like this, like a is equal to v, this ds over dt will be v, and dv over ds we can write it like this. Other way of writing is v dv is equal to a ds. We are going to integrate it. Initial, like v dv is equal to a is constant, integration ds. So initial velocity was, you can say initial velocity was u, final velocity was I am making it v1. Okay, so initial velocity was v, final velocity was v1, and this distance, initial distance was 0, final distance was s. So initial distance was 0, final distance was s. So like I told you, when this type of integration comes, like I told you, it will become v1 plus 1 over 1 plus 1. Okay, this is u, this is v1, and what it will become, a s, 0 to s. So what this will become, like it's v square over 2, v square over 2 u into v1 is equal to a s minus 0. So what it will become, v1 v1 square over 2, we have to use this integral and differential calculus, so we will be using all these things. So for the time being, I think it's enough, and we will be discussing more into it in our future classes or next classes. Okay, so that's all for today. Thank you. ये पहुंचा ही नहीं है।